Did you know there's a cool time-saving shortcut to solve this integral faster than integration by parts? Be sure to ninja kick that subscribe button and become a ninja today so you can save yourself some valuable time on your next exam. For sine squared of x dx, a faster method I want to use here is using trig identities. Now, you don't have to remember all the trig identities out there, but there are a few that are really important, so I highly recommend just writing down these key identities you should memorize to see if we can come up with another expression for sine squared of x that's much easier to integrate. So the three I highly recommend you remember is the cosine squared of x plus sine squared of x equals 1. That comes from the unit circle. And then we have sine of 2x is the same as 2 sine of x cosine of x. And then finally, we have this identity here for cosine of 2x. Now, if you were to use any one of these trigonometric identities by itself, it doesn't really make the problem easier to work with. However, there is a way that you can recognize, you know what, sine squared of x appears in two of these. Can I combine the first and third identities here in such a way to rewrite this integral to be easier to work with? Give it a thought, leave a comment below and see if you see it. Okay, so what I want you to recognize is that because sine squared of x appears in both the first and the third identities here, we should look at an opportunity where for the third identity, cosine of 2x, because you have cosine of squared of x in there, maybe we can actually find a way to substitute in what cosine squared of x is in terms of sine squared of x. And the way you can do that is looking at the first equation. Because cosine squared of x plus sine squared of x is the same as 1, we can solve that for cosine squared of x to find this new expression where cosine squared of x is the same as 1 minus sine squared of x. And what I want to do here is for the trigonometric identity for cosine of 2x, on the right-hand side where I see this cosine squared of x, I want to substitute in that it's the same as 1 minus sine squared of x, giving an expression that's really valuable now because on the right-hand side, everything is now conveniently written in sine squared of x terms, which is the same as the integral that we're working with, which means that once we simplify this, if we can rewrite this expression as sine squared of x equals something, well, that something is now something we can put into our original integral expression that's easier to work with. So I'm going to simplify the right-hand side, giving cosine of 2x equals 1 minus 2 sine squared of x. And I want to solve now for sine squared of x. So in one swoop, I'm going to add 2 sine squared of x to both sides and also subtract cosine of 2x on both sides of the equation, giving 2 sine squared of x equaling 1 minus cosine of 2x. And then finally, I can isolate the left-hand side for strictly sine squared of x by dividing both sides by 2, giving a new expression or trig identity that says, hey, sine squared of x is the same as 1/2 minus cosine 2x over 2. And see, we didn't have to remember that identity. We were able to create it by using the identities that we wrote above. How cool is that? So now I'm going to rewrite the original integral. So because sine squared of x is the same as what you see on this right-hand side of the equation, we're going to put that right-hand side under the integral here. And because we see some subtraction going on here, remember that when you take the integral of a minus b dx, you can break that integral up into parts. And I'm going to do just that. So on the left-hand side, I'm going to bring the 1/2 outside of the integral because it is a constant, giving me 1/2 times the integral of dx, and then minus this other part, which is 1/2 times the integral of cosine of 2x dx. And already this is much easier to work with because the left integral is a constant, and the right one looks like a u-substitution by inspection. So for the left-hand side, when you integrate 1/2 times the integral of dx, you get 1/2 x plus c. I'm going to drop the plus c for now because I still have an integral in my expression. I'll add it at the end. And then for this cosine of 2x part, remember you can let u equal 2x, and then taking the derivative of both sides with respect to the variable you see, you will find that du is the same as 2 dx. But because we have dx in the expression and not a 2 dx, we need to divide both sides by 2 so that we can substitute in du over 2 for dx. And now we have an expression where it's 1/2 x minus 1/2 times the integral of this new integration that we have after a u substitution of cosine of u times 1/2 du. Because remember, when you substitute it in for dx, you introduce this 1/2 constant there. And what I'm going to do is I'm going to bring that 1/2 constant outside of the integral. And because we already have a 1/2 there, 1/2 times 1/2 will give me 1/4. And now what appears under the integral expression is just a cosine of u du expression. That's much easier to work with. And if you remember, the integral of cosine of u is sine of u plus c, but because u is 2x, I simply substitute that back into this final answer.